video, I want to talk about every forms of quadratic functions. What it means by the axis of symmetry, which is one of the properties of y is equal to x squared graph. If you think about in terms of this graph, if you move it right over here, according to a parabol's definition, is that if you pick some special points, so we figure out the second properties of y is equal to x squared graph. And let's think about in terms of a third example, third properties. And for a third property, it is that when the x value is less than 0, y value decreases, and when the x value is greater than 0, y value increase. So let's think about in this term when the x value decreases. So when the x value is less than 0, which means the x value is negative, the y value decreases, and we can actually prove that. And let's think about it in terms of when the x value is negative 2. When the x value is negative 2 right over here, the y value looks like it hits positive 4. Let's think about it in terms of when the x value is negative 1. And when the x value is negative 1, it looks like the y value is positive 1. So we can clearly see that the y value decreased. At first it was 4, but the y value right now is 1. As it goes to the positive, the y value decreases. So we actually proved that. And let's think about it in terms of next one, when the x value is greater than 0, which means the x value is clearly a positive value, the y value increase. So we can actually prove that. Let's think about in terms of when the x value is positive 1. And then when the x value is positive 1, it looks like it hits positive 1, the y value. Let's think about in terms of when the x value is positive 2. When the x value is positive 2, it looks like it approximately hits positive 4 for the y value. So we can clearly see that the y value was 1 at first, but the y value is right now 4, which means it increased 3 times. So we actually proved it right over here, which was our properties of y is equal to x squared graph. Now I'm going to compare this y is equal to x squared graph with the other quadratic functions graph. So let's think about in terms of a next graph, y is equal to x squared graph, which we added the coefficient of the x squared term, which is a in this case. Characteristic cases of the y is equal to x squared graph, where the a, which is a coefficient of the x squared term, is shown by its numbers. The 6 cases are, first of all, y is equal to 2x squared, opposite one where y is equal to negative 2x squared, and then y is equal to x squared, and the opposite of that, y is equal to negative x squared, and then for the last, y is equal to 1 over 2x squared, then y is equal to negative 1 over 2x squared. Think about in terms of properties of y is equal to ax squared graph. The property of y is equal to ax squared graph is that if the a is greater than 0, the graph goes upward, and when the a is less than 0, the graph goes downward. And we can think about in terms of a. If we think about a in our quadratic function, a is a coefficient of the x squared term. So at first we can actually prove that when the a is greater than 0, which means the a value is positive, the graph should go upward. So if you look at our 3 examples of y is equal to 2x squared, y is equal to x squared, y is equal to 1 over 2x squared, they're all in the first and second quadrant, which means they're all positive. And if you look at our a value, which in this case 2x squared is 2, and the x squared is just 1, and the 1 over 2x squared is 1 over 2. They're all positive, and their graphs goes upward. And let's think about the case when the a is less than 0, which means the a value is negative. The graph goes downward. And if you think about these three cases where the graph goes downward, at first y is equal to 1 over 2x squared. Negative 1 over 2 is a case when the a value is less than 0. And if you think about the second one, y is equal to negative x squared. Negative 1 is a case when the a value is less than 0. And if you think about the third one, negative 2x squared, negative 2 is a case where the a value is less than 0. So we can actually see that when the a value is less than 0, the graph will go downward. So we can actually see that the value of the a, which is it is positive or negative, it defines the format of a function. When the a sign is positive, the graph goes upward like these three cases. And when the a value is less than 0, which means when it is negative value, the graph goes downward like these three cases. The second property of y is equal to x squared graph. The second property is that the origin can be either minimum or maximum point. And we have learned that the origin is a case when the x value is 0, the y value is 0. Think about it in terms of origin can be either minimum or maximum point. The minimum point will be the case when the a value is greater than 0. And we can actually prove that the a value is greater than 0, which means a will going to be positive, will going to be these three cases. And let's just think about this case through y is equal to 2x squared term. And x term in this case will going to be input of our function. I'm going to show a lot of kinds of quadratic functions graph from the basic and compare all of them. So whenever we input the value of negative, let's say negative 1, and it will going to be 2 times negative 1 squared, which this term will just turn to 1, and they're going to give us output, which will going to be 2. So that means whenever we input the value of negative for this term when the a value is greater than 0, for this ax squared term, there won't be a negative output, which means there won't be a negative point, and that could say that it will be a null graph that are shown in the third quadrant and the fourth quadrant. So the origin in this case will going to be a minimum point. And let's think about in terms of when the origin becomes a maximum point. The maximum point will going to be when the a value is less than 0, which means it will going to be negative. So for the negative one, there are three cases right over here, and let's just pick one of them as our choices. So let's pick y is equal to negative 2x squared as our choices. So y is equal to negative 2x squared. And even though we input the value of the positive to our x value, positive times negative turns to negative. And even though we input the value of negative, such as negative 1, it will going to be y is equal to negative 2 times negative 1 squared, which this term turns to positive, and times negative will turn to negative output. So that means even though we input the positive and the negative value, they will all turn to negative output, which means there will be no positive values, and the maximum point will going to be origin, which is 0, 0. And we actually proved why the origin can be either minimum or maximum point. It depends on the a sign. It is positive or negative. For the third property is that if the absolute value of the a is big, the width of the parabola will be small, and we can prove it through our cases right over here. So in order to prove the third property of y is equal to x squared graph, we need to have a three examples, which I will choose y is equal to x squared, y is equal to negative 1 over 2x squared, and y is equal to negative x squared. So if you write it down, so according to our property, we only care about this absolute value of a, which means we don't care about the negative, we only care about the positive value of a. So at first, if you think about the first term 2x squared, the a value will going to be 2. And for this term, even though it's negative 1 over 2, the absolute value is 1 over 2. And for the negative x squared, the coefficient of the x squared term is negative 1, but the absolute value is negative 1, positive 1. So if you compare these three, we can think that according to our property, the y is equal to 2x squared width is the smallest. But if we actually see through our graphs, we can see that y is equal to 2x squared graph, which I'm pointing out, is its width is our smallest comparing to other graphs. And if you think about the y is equal to negative x squared graph, according to our theorem, it should be the width of it should be smaller than 1 over 2. So, but if you actually prove that, it is actually right that the y is equal to negative x squared graph that I'm pointing out, its width is smaller than the y is equal to 1 over 2x squared graph that I'm pointing out. So we actually proved that if the absolute value of the a is big, the width of a parabola will be small. Learn about y is equal to x squared graph, and let's think about in terms of y is equal to ax squared plus q graph. This here is that I drew a approximate value of y is equal to ax squared plus q graph. The reason why I said y is equal to ax squared plus q graph is the approximate value is that we know that y is equal to ax squared graph right over here that I drew in the dotted line. For a q is a constant. Constant means there's a number without any variables such as x. But we don't know exactly about the q if it's negative or positive. So also we don't know exact value of q, but I drew the approximate value of it. Y is equal to ax squared plus q graph is q is a value of a y, which mean by that is, so the dotted line is in y is equal to ax squared graph, but we moved to the y-axis direction for a q times. So that means the y direction for a q times. And so that's why I moved up to the for the q times, and this distance right over here, this distance is q. And let's talk about in terms of y is equal to ax squared plus q's graphs property. First property of y is equal to ax squared plus q's graph is that it is a transformation of y is equal to ax squared graph that I drew in a dotted line that move to the y-axis direction for q times. And this is a thing that we talked about through our graphs. And q is a number which can be negative or positive. If it is positive, it will go upward, and if it's negative, it will go down. The second property of y is equal to ax squared plus graph x squared plus q graph is that it has its vertex as 0, q, and y plane is its axis of symmetry. So at first, let's think about in terms of our most basic function graph y is equal to x squared graph. The reason why it has vertex as 0, q is because ax squared plus q's graph is a transformation of y is equal to ax squared graph to the y direction, y-axis direction. And for the ax squared graph, the origin point can be either maximum or minimum, and I will just call origin as 0, 0, which the x value and the y value are both 0. And if you think about ax squared plus q squared, for the q value, that means we transform ax squared graph to the y direction, which means the y value of this coordinate will gonna be changed, but the x value will gonna be still because we didn't move it to the x direction. So if you think about it, let's think about the case when the a value is positive. When the a value is positive, as we have learned, the a value is positive, the graph goes upward, which is exactly this case right over here. And if let's say we move the q times, we don't know if it's negative or positive, but if you think about q value into positive, this distance between the origin point and this point will going to be aq. That means the x value is still because it is on the y-axis, which means the x value is equal to 0, and the y value will going to be q. So if you think about it, when the a is positive, which means when the a is greater than 0, the minimum point, so the minimum point will going to be 0, which x value is 0, and the y value will going to be q. Let's think about in terms of when the a value is less than 0, which means when it is negative. As we have learned, when the a value is negative, the graph goes downward. So if you transform this into downward, it will going to be like something that look like this, approximate value. But we have moved into a q times, and it can also be in the up. It depends on the value of a q. And this term right over here, the only maximum points exist as it keeps going down. And the maximum point, the x value, will going to be 0, as we have knew that it is on the y-axis. And the maximum point will going to be a q. And the q defines the maximum or minimum points y value. So when the a is less than 0, the maximum point will going to be 0, q. Let's think about in terms of y is equal to ax squared plus q squared. Example of as y is equal to 2x squared plus 4. And we could have just graphed this one, but before we think about it using our property, this means we rotated 2x squared graph to the y direction 4 times. So if you actually compare it, let's draw 2x squared graph first. So for the 2x squared graph, y is equal to 2x squared. If you input 0 to the x value, it will turn into 0. And let's think about the easy points to graph, which will going to be 1 squared. So y is equal to 2 times 1 squared, which will turn into positive 2. Now let's think about it in terms of negative 1. For the negative 1, y is equal to 2 times negative 1 squared is equal to 2. It also is equal to 2, so we can write that down. So we can figure out that, as we have learned, if there is no constant, the origin will going to be its minimum or a maximum point, depends on the a value. The reason is because even though we input the value of the negative, the positive output will going to come out, which means it won't steal in the third quadrant or fourth quadrant, which shows its negative value and a negative output. So we can say that the 0, 0 is minimum point, as we have seen the a value is a positive 2. So we can actually graph that with this 3 points. So if we actually graph it, at first let's graph 0, 0 first, then 1, 2, 1, 2, negative 1, 2. So we can approximately see that the graph will gonna be something that look like this. And this is the approximate value of y is equal to 2x squared graph. But as we have learned, the 4 means is a positive 4, which means we're moving a positive 4 to the y direction, y-axis direction. So if you move 1, 2, 3, 4, the graph will going to be something that look like this, that satisfy this equation right over here. And these are same, but this difference between both of them is that for this graph it moved y is equal to 2x squared graph to the 4 to the y-axis positive direction. So that's the what the y is equal to ax squared plus q's graph means. And let's talk about the next graph. Think about it in terms of y is equal to a times x minus p squared graph. Equal to a times x minus p squared graph also starts from a basic one, which is y is equal to ax squared graph. But for y is equal to ax squared plus q graph, for ax squared graph, it is a transformation of ax squared graph that moves to the q direction, which is y direction for q times. And it is opposite with a y direction, which means for y is equal to a times x minus p squared graph, moving the graph to the right or the left direction, which is directly to the x-axis direction. Think about y is equal to a times x minus p squared graph. For the a, it is just a number that defines a graph format, whether it goes downward or upward depends on the a's value, if it's negative or positive, and it doesn't really affect when it comes to graphing a graph. And for x minus p squared, and we can see that the y is equal to ax squared graph right over here. We move that graph to the p times to the x direction. So that means it can both be positive x-axis and it can be also negative x-axis, depends on sign of the p. And let's think about it in terms of a p. So for the y is equal to a times x minus p squared graph, and for the p, the way we write it is that if the p-value is positive value, we write it as negative. And this is how we write it. And for when the p-value is negative, we write it as positive. And if you look at our a times x minus p squared, negative p, which means the p-value will going to be positive. So if you think about in terms of examples of a times x minus p squared graph, before you think about the example of y is equal to x minus p squared graph, let's think about in terms of properties of y is equal to a times x minus p squared graph. For the first property of y is equal to a times x minus p squared graph is that at first when the a value, which is a coefficient of x minus p squared term, and if it is positive, which means it is greater than 0, the graph will go upward. And when the value is negative, which means if it is less than 0, the graph will going to go downward. And for the value of a, we need to remember that it is just a case, it is just a number that defines a downward or upwards graph format. And only thing that we need to carry in, say, behind of the a term, which in this case will going to be x minus p squared graph. And if the a term is positive, we could have just graphed it with x minus p squared. But if it's negative, at first we draw x minus p squared graph and then we go downward. The property of y is equal to a times x minus p squared graph is this graph is a transformation of y is equal to ax squared graph right over here. And for the p times, it moves p times. P is a number, which means it is a variable, and that can be either positive or negative. And it moved to the x-axis direction. If we compare with ax squared plus q graph, for this graph, y is equal to a times x minus p squared graph. We move the graph, which is the basic of y is equal to ax squared graph, to the right or left direction, which means it goes to the x direction. But for the y is equal to ax squared plus q's graph, we translated y is equal to ax squared graph to the up or down, which means we moved it into a y-axis direction. The third property of y is equal to a times x minus p squared graph, it is the vertex of the parabola will going to be p comma 0, and the axis of symmetry is the case when x is equal to p. The reason why y is equal to a times x minus p squared graph vertex is p comma 0, it is because we know that is a transformation of y is equal to ax squared graph, and we have learned that there can be both minimum or a maximum point, depends on the value of the a, and the minimum or maximum point will going to be origin, which means 0, 0, and which means x value is 0 and y value is also 0. But for the a times x minus p squared graph, we moved the graph to the x direction. That means the x number of coordinates of x will change, but not the y one. So we don't know exact value of the x, so we just do it with p, which shows a distance how we moved. So we're going to be p, but the y value, we didn't move for the y value, which we're going to be up or down, so we can just count it as 0. So that's why our vertex of this function is p comma 0. And for its axis of symmetry, they said axis of symmetry is when the x value is equal to p. If you think about this case, a times x minus p squared graph is a case right over here, and it will going to be approximate value because we don't know exact value of the a and as well as p. And also there is no axis of symmetry. Axis of symmetry is a straight line that hits the middle of a parabola. For the y is equal to x squared graph right over here, its axis of symmetry is when the x value, when the y value exists, which means it is on the y-axis. And for here, there is no axis of symmetry, so we can actually make it. The standard of the axis of symmetry is its minimum or maximum point, but in this case we're going to be a minimum point. And if you make a straight dotted line to that hits its the parabola's minimum point. For the minimum point, it is a case when the x value exists, I'll call it p, and the y value is equal to 0. And we always need to remember that the minimum point or maximum point should be a standard of its axis of symmetry. So we need to find a case when the x value exists and the y value is equal to 0. So if you think about it, this graph right over here, a times x minus p squared, that is equal to y, but we know that y in this case will going to be 0. In order to make it into 0, the a value should be 0, or inside of this parenthesis should be 0. But usually if you make this inside 0, it will obviously gonna be 0. So we can think about in terms of x. When the x value is equal to p, this whole expression makes 0. The reason is because if we input the value of the p into x value, it will going to be a times p minus p squared. That should be equal to 0. P minus p will cancel out as 0, and then square is just 0 times a will just make it into 0. So the axis of symmetry is the case when the x value is equal to p. So what I did here is that I drew y is equal to x squared graph on the coordinate plane. And I'm going to talk about this graph right over here in the xy plane about the properties of a y is equal to x squared graph. So let's think about it in terms of two examples of y is equal to a times x minus p squared graph. And I'm going to pick two cases when the x value is positive and when the x value is a value is negative. So it will going to be at first x minus 2 squared, and then that is equal to y. And then other one is y is equal to negative x plus 4 squared. And these are my two examples of the y is equal to a times x minus p squared graph. Let's think about it in terms of our first example of y is equal to a times x minus p squared graph. X minus 2 squared is equal to y. And if you write it down again, x minus 2 squared is equal to y. We can know several things that the a value turn into 1. That means it is a positive, so the graph will go upward according to our definition. And also we can know a lot of things here that even though we input the value of negative, let's just input the value of negative 1 simply, negative 1, negative 2, and then squared. Negative 1 and then negative 2 turn to negative 3, squared is positive 9, which means even though we input the value of the negative, it will just turn into positive. So that means there will be a no negative minimum value. We know that the vertex will going to be minimum value, and there will be a cases where only when the y value is equal to 0. And for this term right over here, the vertex will going to be when the x value is equal to 2, these terms, so this term turns to 0, we get y value is equal to 0. So this is our minimum vertex for our function. So let's graph this first. When the x value is 2, the y value is 0. So this will going to be our minimum point of our x minus 2 squared is equal to y function. And if you think about more points, let's think about in terms of when the x value is equal to 3. When the x value is equal to 3, it will going to be 3 minus 2 squared. And that should be equal to 3 minus 2 is just positive 1. Positive 1 squared is just positive 1. So when the x value is 3, the y value will going to be 1. So when the x value is 3, the y value will going to be 1 right over here. And let's think about the case when the x value is equal to 1. When the x value is equal to 1, it will going to be 1 minus 2 squared. 1 minus 2 will just turn into negative 1, and the square will just turn into 1. So we can think about when the x value is 1, the y value will also going to be 1. So it will going to be right over here. When the x value is 1, y value is 1. So if you think about the approximate value of our graph, it will going to be like something that look like this that passes through our points. If you draw it again, so it will going to be something that look like this that passes through our points that we found, and the vertex, which is the minimum point of our function, will going to be the coordinate is 2, 0. And let's think about the other function, negative x plus 4 squared is equal to y. Let's think about it in terms of a second example of this quadratic functions graph. Negative x plus 4 squared is equal to y. And we can know that a value in this case is negative. So a value is negative value, which means the graph will go downward. And we can see that even though we input the value of the x into positive, let's input the value of 2. If you input the value of 2, we're going to be 2 plus 4 square. But 2 plus 4 is 6. 6 square is 36, but there is negatives. So it will turn into negative 36. So we can see that even though we input the value of a positive, it will still going to be a negative, which means the graph won't go up to the second quadrant or a first quadrant. So we can see that a maximum point of this function will going to be a x-axis. But the x-axis is the case when the y value is equal to 0. And if you think about this term, right over here, if you write it down again, negative x plus 4 squared, if you want to make this term into 0, all you have to do is we can input a value of the x value into negative 4. If you input a value of negative 4, it will going to be negative 4 plus 4 squared, and this whole thing will turn into 0, and we get it is equal to 0. So we got a maximum point. The reason why this maximum point is that if a value is positive, it will going to be minimum value like this term, but it is a negative, which means it only contains a maximum point. The maximum point will going to be the x value is negative 4 and the y value is 0. So if you actually graph it, the maximum point will going to be right over here. So let's just pick other points to graph this function's graph. At first, let's input our value of x into negative 3. If you input a value of negative 3, according to our function, it will going to be negative. Instead of x value, we input negative 3, and then we get positive 4, and then square. And then negative 3 plus 4 is positive 1, and then square will just turn into positive 1, but we get negative, so it will turn to negative 1. So when the x value is negative 3, the y value will also going to be negative 1. So if you graph it, it will going to be right over here. And it's a point negative 3, comma, negative 1. And if you have one more point, we can actually see a approximate value of it. So if you input a value of negative 5, when you input a value of negative 5 according to our function, it will going to be negative the negative 5 plus 4 squared, and this term will turn to negative 1, but negative 1 squared will turn to positive 1, but we get negative, so it will turn to negative 1. So when you input a value of negative 5, it will still turn into negative 1. So here's negative 5 and we get negative 1. So this is a point when the x value is negative 5, the y value is negative 1. So if we graph it, it will going to be something that look like this that passes through our 3 points. And we need to remember that the graph always goes downward. And if you think about these two graphs, this was our basic example of y is equal to 8 times x minus p squared graph. And we have finished up with our properties of this function. Let's go to our last function. Is equal to 8 times x minus p squared plus q graph also starts from y is equal to ax squared graph, but this graph is addition of this graph y is equal to ax squared plus q and a times x minus p squared graph. So for y is equal to 8 times x minus p squared plus q graph, we already know that a is a value that defines a graph's form, quadratic function's graph form, whether it goes upward or downward. And for x minus p squared plus q's graph means we use y is equal to ax squared graph as a basic format. and we transformed it to the y. We moved that graph to the x-axis direction for the p times, and we moved that transformation graph to the y-axis direction for the q times, and this is what this y is equal to 8 times x minus p squared plus q means. But in terms of properties of y is equal to 8 times x minus p squared plus q's graph. The first property of y is equal to 8 times x minus p squared plus q's graph is that it is a transformation of y is equal to ax squared graph. And it is a transformation to the x direction for p times and to the y-axis direction for q times. And this is a statement that we already learned in the up through our graphs, and this is what this graph means. This is what this thing means. Y is equal to 8 times x minus p squared plus q. And let's think about in terms of a second property of this function. So for a second properties of y is equal to 8 times x minus p squared plus q's graph, it is that it has a vertex of p comma q, and then x is equal to p is a axis of symmetry of this function. Talk about in terms of properties of this graph y is equal to x squared graph. So the reason why it has vertex at p comma q is because we know that the basic format of the graph is y is equal to ax squared, and the y is equal to x squared graph is minimum or maximum point depends on the a value. It will going to be a origin as we have learned, which means it is 0, 0. And all we did is x value is 0 and the y value is also 0. And the reason why it has p comma q is because we moved into a p times to the x direction, which means the x value will gonna be changed according to how the distance for changed to the origin. And we don't know exact values, so we just put that into a p. But before this one, the y value is still 0, but we know that we moved this transformation for the q times to the y direction, but we don't know a value of its y direction exactly, so we just put that value into q. So p comma q, that's why it is a vertex of this function. And the reason why the x is equal to p is axis of symmetry is because we know that in order to find the axis of symmetry, the x values are the minimum and the maximum value should be a standard of axis of symmetry. The reason why we need to find the axis of symmetry of 8 times x minus p squared plus q's graph is because for the y is equal to ax squared graph, we know that the axis of symmetry is a case, which is a y-axis, but the standard of its axis of symmetry is the case when the x value, which makes this whole expression turn into 0. And so for this term right over here, if you make a dotted line, all you have to see is a value of the x, which turns this whole expression into 0. And we also know that this term will going to be a axis of new symmetry. And for the value of the x that makes this whole expression turn to 0 is a case when the x value is equal to p. P minus p turn to 0, and then this whole expression will turn to 0. So we can say that the axis of symmetry is a case when the x value is equal to p. And in order to find the axis of symmetry, all we have to see is that for that quadratic function, the x value which makes this whole expression turn into 0. And if I give an example for this y is equal to 8 times x minus p squared plus q's graph. So before you think about our examples of for this function, let's think about in terms of this form of our quadratic function. For this quadratic function, y is equal to a times x minus p squared plus q. We call this as a vertex form. The reason why we call it as vertex form is that using this format we can find the function's vertex easily. The vertex of this function will going to be, we don't care about the a value. The vertex of this function will going to be x comma q. But we also need to remember is that if it's a negative p, we always should write opposite, which means when the p value is negative, x value should be positive, and when the p value is positive, the x value should be negative. And that's the case how we find the vertex of a function. So if you think about a first one, y is equal to x plus 4 squared plus 2. The vertex of this function, at first the p value is 4, which means the x value should be opposite of that, which will going to be negative 4. Then if we input a value of negative 4, this term will just cancel out as 0, and we get a y value, which is a constant, will going to be 2. So negative 4 comma 2 will going to be our vertex of our function according to our vertex form property. So if you graph it negative 4 comma 2, it will going to be right over here. And the coordinate is negative 4 comma 2, and this is our minimum point. So if we graph more points, we can actually find easy points to graph when the x value is negative 1. When the x value is negative 1, negative 1 plus 4 is positive 3 squared, then plus 2. 3 squared is 9 plus 2 will going to be 11. So we can actually graph that negative 1 and 11. I will just write an approximate value right over here. Now let's think about it in terms of a case when the x value is negative 3. When the x value is negative 3, negative 3 plus 4 is positive 1. Square plus 2 will turn into 3. So we can actually graph that. It will going to be right over here. And let's think about in case when the x value is negative 5. When the x value is negative 5 right over here, it will going to be negative 1 squared plus 2, which will just turn to positive 3. So it will going to be right over here. So if we actually graph it, it will going to be something that will look like this that passes through our points. So this is our quadratic function. And let's look at our other example. Y is equal to negative x plus 1 squared minus 3. And let's look at our vertex at first. But before I do that, we figure out the a value, which is negative, which means the graph will go downward. So our vertex of this function will going to be the p value is 1, which means the x value should always be opposite of it, which will going to be negative 1. And if we input a value of negative 1 into x value, this term will cancel out as 0, and we get an output of our y, which will turn into negative 3. So if we actually graph it, so I'll write our function here, y is equal to negative x plus 1 squared minus 3. We figure out our vertex negative 1 come negative 3, which will going to be right over here. And this will going to be our maximum point. And let's look at our other points to graph this function. At first, let's input our value of positive 2. If we input a value of positive 2 plus 1 is positive 3, squared is 9, but there's minus, so we can write minus 9, and then we have minus 3, which will going to give us negative 12. So you will going to be approximately right over here. And let's think about in case of when the x value is 1. When the x value is 1, 1 plus 1 will turn into 2, and then minus, so minus 2, and then minus 3 will turn into negative 5. So we can actually graph that. It will going to be something that look like this if we graph it. And it will going to be approximate value because we don't have enough spaces for our coordinate plane. And we figure out two cases using our y is equal to 8 times x minus p squared plus q's graph. So we have learned about the five main graph of our quadratic function. And if I review it, y is equal to x squared graph. This graph passes through the origin and it always should be a minimum point right over here. The reason is because there is no a term, so since we input a value of a negative value into x value, it will going to square it, which will going to give us a output of positive value. And we need to remember that when the x value is greater than 0, the y value decreases as we have seen here. And when the x value is greater than 0, y value also increases. Let's think about it in terms of y is equal to ax squared graph. And y is equal to ax squared graph is the addition of the a, which defines the quadratic functions format, whether it goes upward or downward. And it was a basic format, it was an advanced format of y is equal to x squared graph. And we need to remember that the origin, which means 0, 0, can be either minimum or maximum point, depends on our a's value sign. And we also need to remember that if a absolute value of a value is big, the width of the parabola will be small, like this case. And for y is equal to ax squared plus q, y is equal to ax squared in our same with this quadratic function, but all we did is we transformed it, which means we moved its quadratic function graph to the y-axis direction for the q times. And it will gonna have a vertex at 0, q as we have proved it. And also for y is equal to 8 times x minus p squared graph, we need to remember that it is a transformation of y is equal to ax squared graph, which we transformed it and we moved that quadratic functions graph for the p times to the x-axis direction. And it will have a vertex p, q, and its axis of symmetry is when x is equal to p. And in order to find the value of axis of symmetry, we also need to remember that it will going to be a x value will going to be standard, which makes this whole expression turn into a 0. And for the last one, y is equal to 8 times x minus p squared plus q's graph. It is a transformation of y is equal to ax squared that added both of these two graphs. And that means we moved y is equal to x squared's graph to the x direction for the p times and for the y direction for a q times. And we could have find a vertex through this form. And we called it a vertex form. First I wrote one property of y is equal to x squared graph. And first of all, the graph passes through the origin. And for this term origin, it means it passes through the point when the x value is 0, y value is also 0. And the reason is because y is equal to x squared. If we input the value of 0 to the x value, 0 squared will going to give us 0. And also the reason why it passes through the origin, why if we input the value of the 0, it gives us the output as 0, is because there is no constant. If there is a constant such as y is equal to x squared plus 3, if we input the 0 to the x term, still 0 plus 3, we get the output 3. And it is case where it passes through the origin. And in the graph of this function, y is equal to x squared, graph opens upward, in this case. Opens upward means the graph is going up. And I'm going to talk about that cases later when I talk about other graphs property too. We talk about more thing about the origin. Origin is a case right over here where it's 0, 0. And it will going to be a minimum point. It will going to be a minimum point. The reason is because there won't be a negative. There won't be a negative which stay right over here. The reason is because let's say we input the values of the negative. So for the y is equal to x squared, let's input the value of the negative 1 to the x value. If we input the negative 1, we will get y is equal to negative 1 squared, which will still get 1. So since we knew that there is a squared term, whatever we input the value of the negative, they will going to square it and turn it into positive. So that's why there won't be a negative, which is third quadrant and the fourth quadrant. So we can see that this graph's minimum point will going to be origin, which is 0, 0. Talk about in terms of a second property of this graph, y is equal to x squared graph. And the second property is that y-plane is the axis of symmetry of this y is equal to x squared graph.